Hello, welcome guys. This is Tutor PVS and welcome to Phi 1000. This can be any code, can be Phi anything depending which course that you are taking. The fact is that this is introductory physics, or rather foundational physics, so you are still doing the correct thing. All right, so now we are going to focus on dimensional analysis, which is something that you might have heard of. It is just deals with the analyzation of the dimensions of a physical quantity. All right, if we want to analyze the dimensions of a physical quantity, we use dimensional analysis. Now some of you might ask yourself, what is a dimension? Well, a dimension is just something that represents the nature of a physical quantity. All right, so what this dimensional analysis is going to help us is going to help us verify equations. We're going to verify equations in physics. Number two, we are going to derive relationships. All right, we are going to derive what relationships between physical quantities. And number three, it helps us to convert units. We can use dimensional analysis to convert what units. For example, if you're converting from meters to kilometers, that is dimensional analysis. All right, so we need to use what we call fundamental dimensions. Fundamental dimensions. Now, fundamental dimensions, they help us, okay, in solving these problems. And these are length. And for length, we are going to use L. Number two is mass. And for mass, we're going to use capital letter M. And number three is time, of which we are going to use capital letter T. The same way I'm writing them in box brackets. This is how you should represent them. All right. We know that, of course, length is measured in meters, and mass is measured in kilograms, and time is measured in seconds. Keep that in mind. All right, so let's look at some of these dimension formulas. Okay, let's look at some dimension formulas. Okay, so for example, velocity. We know that velocity is just v is equal to distance, then we divide by time. This we are aware, but distance is just length, so we say L. Okay, and time we are going to use capital letter T, and when we express this one using algebra or indices, we end up getting something like this: L stroke T to the power negative, L T negative 1. This is a dimensional formula for velocity. Let's look at acceleration. Okay, let's look at what acceleration is given by acceleration is equal to velocity, and we divide by time. But velocity is here, so we're just getting that one, LT negative 1. We divide by time in bracket like that. And because there are two of the t's, so this becomes LT squared like that. This is the dimensional formula for acceleration. Let's move on. Let me put force. What about force? We know that force is equal to mass multiplied by acceleration. Mass, we are using this capital M. So for mass, we are using capital M in bracket like that. But acceleration, we just found it is there, down there. So we are multiplying by LT squared. Then, of course, we can't have brackets like this. We just need to have one common bracket. LT negative 2 like that. That is the dimensional formula for force. Can you fail? Let's talk about energy. All right. So for energy, we know that energy, or not just energy, but even work. We know that work is force. Work is force multiplied by what? Displacement. So the force is there. So force is here. Excuse me. And the distance is just length, right? distance is just length. So you put a dot there, then you put length. So what do you end up getting? Length and length will give us length squared. So we end up having m L2 to negative 2. This is the dimensional formula for energy or work. What about power? Power is equal to work over time. But work is here, m L squared T negative 2. Over what? Over T. Please don't forget the bracket. Now there are now 3 of the T's, which will give us that L squared T negative 3. Is this what you can fail? All right, but questions don't come like this. This is just the way to do. But how do questions come exactly? Questions come, like I said, we do this to verify equations, derive relationships, and convert units. They can ask you to convert units, but you are going to convert those units using dimensional analysis rules. For example, so what we need to check here is we check both sides. Remember, to prove that something is correct or an equation, you have to prove both sides that they are consistent. So we have the left side and the right side. So let's first start with the left hand side, which is this one there. Let's prove that it's correct. So we're dealing with v, which is just the velocity, right? Okay. So we're dealing with the velocity, right? And we just found what velocity is. Let's go back. Velocity is LT negative 2 as a power. So we have this as LT negative 2. Okay, that's the left hand side. Let's go for the right hand side, okay? So the right hand side is giving us what? The right hand side, we have u plus at, where u is velocity and a is acceleration, where t is time. All right. Okay, all right. So let's branch this into 2. So we have u is still the same, by the way. It's still velocity, so it's lt negative 2. And we have at acceleration was lt. Guys, am I safe here? Sorry. Here I almost made a mistake. Here it's negative 1 and here it's negative 1. It's velocity. Is this one which will give us negative 2? Yeah, fine. I don't want to give us negative 2, but we are multiplying by t. So we get L t. Remember, t and t, same bases. We add the powers, we still get negative 1. All right. So now we are saying u plus at is equal to what? L negative 1 plus L negative 1. Therefore, now, in dimension analysis, and this is why we don't consider numbers, or let me say digits or numeric type of dimensions. We forget. Of course, if I add this one, it's going to give me 2 LT negative 1. But this one is dimensionless, so you forget it. Now, take note that the left hand side was this, and the right hand side is, since this one is dimensionless, we ignore it, is still this. Hence, LS is equal to RHS. You've shown that this is dimension consistent. Hence, dimensionally consistent. Is this what you can fail? No. Now, it will be your duty to prove this one. Prove that, show that this ut plus half 80 squared, show that this one is dimensionally consistent or correct. Cheers.